this reality? We're experiencing something right now, so maybe the better question is, what is reality? Or why is reality? Who are you again? Call me producer. Mr. Producer. I see what you did there, and I think the audience got it too. Let me finish the intro. Could everything we see, everything we experience, and everything that exists in our entire universe be an illusion? Supporters of simulation theory believe that not only is it possible we are living in a simulation, but it's also likely. Wait, is this an episode that would make us question everything by the end of it? Sure is. Then are we in a simulation right now? Maybe. What do you mean maybe? How would we know if you are in a simulation? There is actually a way. The idea of the universe being a simulation is not a new one. Theories exist in ancient cultures around the world. Modern simulation theory comes from Nick Bostrom, a philosopher at Oxford, who wrote an influential paper on the subject in 2003. If living in a simulation is possible, Bostrom presents the simulation trilemma, which says one of the following must be true. 1. We destroy ourselves before we are able to create a simulation. 2. We're able to create a simulation but choose not to. Or 3. We are definitely in a simulation. Bostrom believes each of these is equally likely to be true. That's 3 really bad options. That's what trilemma is. We know, no one likes a smart ass. Now, I don't think that's a controversial idea at all. We already use computers to make models to analyze human behavior, forecast the weather, and entertain ourselves. We simulate everything, and when a civilization becomes advanced enough to create a convincing simulation, the first thing they'd likely to simulate is their own past. Nick Bostrom calls this an ancestor simulation. But a civilization wouldn't stop at one simulation. They make countless ones. And those simulated worlds could create their own simulations, and so on, layer upon layer. Oh, like that episode of Rick and Morty. Exactly like that episode. What is that episode called? I can't remember on the top of my head, but I'm sure someone in the comments will write it and after they subscribe. Oh, nice. I see what you did there. Now, imagine if you're a part of one of those simulations. Believing you have free will. You decide, I want to invent a computer, so you do. Then I want to build a world inside my computer. And that world does the same. It's simulations all the way down. When Elon Musk asked what chances are that we are living in an original-based reality, he said, the odds are 1 in a billion. Neil deGrasse Tyson is more cautious. He puts the chance as 50-50. A 50 chance that everything we know is simulated, that's pretty wild. While we mostly hear from scientists on this topic is not science, simulation theory isn't rooted in equations or physics, it's a branch of philosophy, more metaphysics than hard science. But if we want to know for sure, we just need to find the evidence, and to do that, all you have to do is look. Let's start from the very beginning. There was no space, no time, nothing. All the matter in the universe was crammed into something the size of a tennis ball. And the temperature, a quadrillion degree. Then out of nowhere, the Big Bang happens. Boom! Everything explodes outward faster than the speed of light. Fast forward 14 billion years and here we are, with the galaxies, planets, ice cream and many things. If before the Big Bang there was no space or time, what was there? From a religion perspective, God created everything, sure, but where was He before? What triggered the Big Bang? What made God decide to act? If you ask a physicist what existed before the universe, they'll start talking about quantum foam, dark energy, or something just as mind-bending as the Big Bang itself. Ask a theologian what existed before God created the universe, and you'll get an answer that's just as puzzling. But one thing that might make sense is the idea that the universe was simply dormant. Then someone or something hit run on a program. In that program, which is our universe, all the laws of physics, electromagnetism, gravity are coded in. The speed of light is assigned a value. Blank constants for mass, speed, and time, they are written into the code. All the rules decide how everything works are part of this program. Even consciousness could be part of the simulation. If you haven't heard of simulation theory, this might sound like science fiction. But some of the world top scientists, technologists, and philosophers believe that we are more likely than not living in an artificial reality. Is there a way to know for sure? How do we know? Wait, I'm getting to the point. If we live in an artificial reality, it would make sense for there to be occasional glitches. Philip K. Dick is one of the most influential science fiction writers of all time. Movies based on his books include Blade Runner, Total Recall, Minority Report, The Adjustment Bureau, and plenty others. He believed there are many universes, and sometimes those other realities bleed into ours. He claimed to have visions of this and even wrote stories like The Man in the High Castle based on these visions. He in fact believes that plural reality exists, superimposed into one another by so many film transparencies. One way other realities blend into ours could be the Mandela effect. Oh. The Mandela effect is when a large number of people have memories of events that don't match reality. This is called the Mandela effect because millions of people specifically remember Nelson Mandela died in prison. He didn't. People remember his wife walking beside his casket in a funeral procession that was on television for 2 hours that day. This never happened. Or the Princeton Bears, which people insist were always called the Princeton Bears. People remember the tycoon from Monopoly having a monocle that he never had. What? He didn't? Here's another one. What did Darth Vader say to Luke in The Empire Strikes Back? I know that one for sure. Luke, I am your father. Nope, he never said that. The Queen from Snow White and the Mirror? Mirror, mirror on the wall? Nope.
Magic mirror on the wall, who is the fairest one of all?
My life is a lie. People remember Jiffy peanut butter, but there's no such things. And there's a lot more. A lot more. Personally, I had most of these false memories. The Flintstones, there are 2 T's in the Flintstones. Some remember just one. And what about the Fruit of the Loom logo? I could swear it looked like this, but it doesn't. This is actual logo. No cornucopia or the basket in the back. That's the Mandela effect. So why do millions of people distinctly remember different things? Glitches in the Matrix? Maybe. Philip K. Dick also felt when we experience deja vu, it's because something in our simulated universe changed and a new timeline branched off the current one. We are living in a computer program reality, and the only clue we have is when something variable changed. Ever feel like you lived a moment before? That's because according to Philip K. Dick and the others, you have. Deja vu is the simulating correcting itself with the new information. We live in a huge universe, 200 billion trillion stars, and even if life is rare, you'd think there'd be some evidence of it, somewhere. This is the Fermi's paradox. But according to the Drake equation, there should be over 1 billion technologically advanced civilizations just in our galaxy. And on average, the nearest one should be just a few hundred light years away. But there's nothing. At least not that we can see. So where's everybody? Are we really alone in the universe, or does our program only focus on us? The nature of our reality is one of the greatest mystery out there. The more we take the simulation hypothesis seriously, the greater the chances we may one day prove or disapprove it. How is that? Remember the Fruit of the Loom logo? Hard to forget now. Well, in 2023, after a lot of posts and people claiming to remember that the cornucopia was in fact in the Fruit of the Loom logo, the Fruit of the Loom company came out and said that their logo never had the cornucopia. The fact-checking website Snoops published a deep dive investigation into whether or not the Fruit of the Loom logo has ever had a cornucopia. Snoops said that after publishing its fact-checking, it received hundreds of emails that alleged to prove Fruit of the Loom did in fact previously use a cornucopia in its logos. Wait, where did the shirt come from? Well, some skeptics argue and said that those were knockoff shirts, but the owners of those photos swear that they bought it from an official store. So where did they come from? Come on, speed up to the point. I'm getting there. Now, new hypothesis suggests that all these mass remembrance events and the shirts are actually a parallel universes bleeding into our own. Now, moving on to... Whoa, you're not gonna go past that like you just didn't drop a bombshell. Explain what you just said. About what? The parallel universe thing. Oh, that. Some theories suggest that the first experiment in the Large Hadron Collider at CERN in Europe in 2008 went wrong, horribly wrong, and created a crack in the space-time. Now that crack repeated itself, but with different parameters. Similar how the PC would malfunction and would rebuild its own database, which led to information and even physical matter to end up at our universe. And guess when all those mass remembrance happened? Don't tell me. Yep, 2008. Max Tegmark, a cosmologist at MIT, suggests that the strict laws of physics point to the possibility that we are living in a simulation. For example, the speed of light could be seen as a clever way to prevent us from venturing far too fast. It's like putting a cap on how far your sims can go. Theoretical physicist James Gates thought simulation theory was absurd, at least until he started studying quarks and electrons. He found something that changed his mind. Hidden deep within the equations used to describe the string theory, he discovered error-correcting code. Wait, seriously? We're talking about real computer code? Yes, actual strings of ones and zeros, computer code. Dr. Gates has completely changed his view on simulation theory because of this, and it doesn't stop there. In 2017, scientists at the University of Washington managed to embed computer code into strands of DNA. Think about it. Everything in nature follows mathematical pattern. Take the Fibonacci sequence. Sequence what now? The Fibonacci sequence is when you add two previous numbers together. 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, and so on. It's the sequence that gives us the golden ratio, also known as phi, about 1.618. You can find this ratio everywhere in nature. For example, in the petals of flowers, lilies have 3 petals, buttercups have 5, chicory have 21, and the daisies have 34. The spacing of each petal forms a spiral based on the golden ratio, and it's not just plants. Animals follow the same patterns. For instance, the ratio of female to male honeybees in a colony is 1.618. The golden ratio. Even our own bodies follow these rules. The length of the arm from your shoulder to elbow and from elbow to fingertip, yep, it's the golden ratio. Even DNA, down to its structure, is built on Fibonacci numbers. From the spiral of the seashell to the spiral of a galaxy, Fibonacci numbers and the golden ratio show up everywhere. It's like nature is following a program. A program? Wait, did we just prove the simulation theory? That's the same reaction some scientists had when they claimed it's just a coincidence that humans are programmed to find a pattern in chaos. But the irony is, by trying to debunk the idea of a simulation, they might actually be proving it. Everywhere we look, whether at something as small as an electron or something as massive as a galaxy, everything seems to follow specific patterns and rules. No matter what we study, all seems to behave like a part of a larger design. And that's the mystery. But if was the universe just one big program? To simulate an entire universe, you'd need way more advanced technology than we have right now. But that doesn't mean we won't get there. Moore's law tells us that computing power doubles every 18 months, and this has held true for about 50 years. It's slowing down a little due to physical limitation. But if we figure out how to make microchips smaller, and we probably will, it's predicted that artificial intelligence could surpass human intelligence within the next 100 years. Elon Musk often points out that when he was a kid, the most advanced video game in the world was Pong, just 2 rectangles on screens. But now, 40 years later, video games technology is almost indistinguishable from reality. He said that 6 years ago, and since then, graphic engines like Unreal Engine 5 have gotten even more realistic. Just imagine what games will look like in another 8 years, or even 100 or even 1,000. That's wild, but how big of a computer would we need to simulate an entire universe? Good question. Well, it's stimulated that there are 10 to the power of 80 atoms in the universe. That's a ridiculously large number. 1 and 80 zeros. If each particle needs 128 bits to calculate its position and momentum, you are looking at 10 to the power of 83 bits just for storage. And we haven't even talked about the computing power needed to track what each of these particles is doing. If you assume 2 floating point operations and second per particle, that's 2 multiplied by 10 to the power of 80 flops, and that's just for the atoms in the universe. If we add human intelligence to the mix, it gets even crazier. The human brain can perform 100 trillion calculations per second, or 100 teraflops. Multiply that by billions of people, and yeah, it's mind-blowing to power all of this. The simulation would need access to something like a Dyson sphere, those megastructures that capture 100% of the star's energy, or maybe even tap into a black hole. Hold up, with those kind of numbers, is this even possible? Well, that's why physicists like Dr. Michio Kaku are skeptical of simulation theory. He argues that the only computer capable of simulating a universe is the universe itself. But with all due respect to Dr. Kaku, that's not exactly how simulations work. Think about a 3D video game. The entire game world isn't rendered at all at once. Instead, the game engine only calculates what the player can see and interact with at that moment. If we were living in a simulation, it would make sense for the creators to use a smaller approach. Wait a minute, do we have a proof of this? Maybe. I knew it. Supporters of simulation theory often point to video games as a way to explain or even prove that our reality might be artificial. In a video game, the only data rendered is what the player sees or interacts with. For example, if there's a car or building in the distance, the game engine doesn't fully render it. It just shows enough of it to make it look real, usually just as a few pixels. And as you get closer, the engine renders more detail, but still just a facade. It doesn't calculate what is inside the building until you actually go in. Like that episode of Rick and Morty, I think. Exactly like that episode. You are referencing Rick and Morty a lot today. Well, it's a show for smart people, and as you can tell, I'm smart. Anyway, the game engine only processes what's necessary, nothing more. If we live in a simulation, our reality could be rendered in a similar way, and we can actually test this idea. Wait, we can test this? How? The double slit experiment is a great example. Here's how it works. When four fire particles, like electrons in a straight line through a single slit at a screen, we get a clumping pattern. If we do this with waves, we get a wave pattern, where the particles spread out in a more even distribution. But when we add a second slit, things get really interesting. Waves passing through both slits create an interference pattern, where the two waves intersect and cancel each other out in some areas, forming a pattern like this. Now, if we fire electrons through two slits, we'd expect to see two clumps since electrons are particles, but instead, we get a wave interference pattern. This doesn't make sense, because electrons are supposed to behave like particles, not waves. For a long time, scientists thought that electrons were colliding with each other, creating the wave pattern. But in the 1960s, the experiment was modified to fire one electron at a time through the slits, so there's no way they could interfere with each other, and yet the wave pattern still appeared. To figure out what was happening, scientists added a detector to observe the electron as they passed through the slits. Here is where it really gets weird. When the detector was turned on, the wave pattern disappeared, and the electron behaved like particles again. But when the detector was turned off, the wave pattern returned. It's as if they knew they were being watched. Wait a minute, the electrons changed just because they were being observed? That's right, and it gets even more stranger. Physicist John Wheeler proposed something called a delayed choice experiment. In this version, photons pass through the slits as wave, but the detector isn't turned on until they are already passed through the slits, just before they hit the screen. Even though they started as waves, as soon as they were observed, they acted like particles. But here's the kicker, they behaved as if they had always been particles, even retroactively. Hold up, you are saying that the particles changed their behavior back in time? Exactly. It is as if the decision to observe them reached back and altered their past behavior. Wheeler's experiment shows that, in some sense, these particles may be aware of being observed. or at least responding to observation in a ways we can't fully explain. Still, don't think there's some kind of intelligence at work here? Oh, you are going to love this. Personally, I find myself leaning towards the information theoretic view, believing that the universe I exist in is a very high quality simulation. Now imagine this. We are observing an experiment happening on a table in a lab, a very short distance. But what happens when we observe light from much farther away, say from a galaxy 100 million light years away? Wait, how would that work? If light from a distant galaxy is projected through the double slit, it behaves like a wave and creates the wave interference pattern, just like in the lab. But if we measure those photons, forcing them through a measuring device, the wave collapses all the way back to the galaxy. This phenomenon is called retrocausality. In other words, by choosing to observe the photons, they reach back 100 million years and change their state on the other side of the galaxy. But here's the key part. Just like in a video game engine, this only happens if we are looking. The universe could be full of galaxies, but those galaxies might not actually exist in full detail unless we observe them. If we are living in a simulation, stars and galaxies could be simple projections, and only when we get up close did they become more detailed. It's an efficient way to save computational resources. And think about it. We have the speed of light as a hard limit, making it difficult to travel far off places. That's a pretty useful rule to have in place if you're trying to keep a simulation running smoothly. But what about quantum something? I forgot what it's called. You mean quantum mechanics? Like the double slit experiments and quantum entanglement, it only makes sense if there is a program running behind the scenes. Because let's face it, only something like a program can completely ignore the laws of physics and even time itself. In a simulation, these strange behaviors fit perfectly. A convenient thing about simulation theory is that you can disprove it. The Big Bang, that's just a simulation putting up. Haven't found any aliens? Well, they are not part of the simulation. Why do UFOs seem to violate the laws of physics? Because they are programs controlled by the simulation creators. They don't have to follow our laws of physics. So who exactly created the simulation? Well, that's the big question, isn't it? When you think about the simulation creator as an omniscient being, existing outside of our understanding of space and time, it starts to sound a lot like you're describing God. And just like you can't prove we are not a simulation, you can't prove there is no God. If something miraculous happened or something terrible, you could just as easily say it's part of your simulation as you could say it's part of God's plan. What's interesting is that many supporters of simulation theory are actually atheists. They reject the idea of God as outdated superstition. On the religious side, some argue that if there is no God and life is just simulation, then nothing matters. Without God to guide us or punish us, depending on what you believe, our actions have no real consequences. Even if we don't live in base reality, we still live in our reality. Our actions here have real consequences. When it comes to what happens after we die, whether we are in a simulation or not, nobody really knows. Wait a damn minute. Didn't you say in the intro that there was a way to check if we are in simulation? I did. Where is it? Speak! Alright. Assuming that the universe is indeed a simulation, then what sort of experiment could we deploy from within the simulation to prove this? It is reasonable to assume that the simulated universe would contain a lot of information bits everywhere around us. So detecting these information bits will prove the simulation hypothesis. The recently proposed mass-energy-information equivalence principle, suggesting mass can be expressed as energy or information or vice versa, states that information bits must have a small mass. This gives us something to research for. Scientists have postulated that information is in fact a fifth form of matter in the universe. They have calculated the expected information content per elementary particle. These studies led to the publication in 2002 of an experimental protocol to test this prediction. The experiment involves erasing the information contained inside elementary particles by letting them and their antiparticle annihilate in a flash of energy, emitting photons or light particles. Scientists have predicted the range of expected frequencies of the resulting photons based on information physics. The experiment is highly achievable with our existing tools, and there is a crowdfunding campaign to achieve it. The link is down below if you are interested. There are other approaches too. The late physicist John Barrow has argued that a simulation would build up minor computational errors which the programmer would need to fix in order to keep it going. He thinks we might experience such fixing as contradictory experimental results appearing suddenly, such as the constant of nature changing. So monitoring the values of these constants is another option. Not the answer I was hoping for, but I'll settle for that. Great. So whether they believe in God or simulation theory, people argue that faith and science don't mix. But isn't that a bit hypocritical? When you really think about it, what's the difference between believing in God and believing in a simulation? Hey, thanks for hanging out with us today. Hit that like and subscribe button. Tell us what you think about today's episode in the comment section below. My name is Jeff, and this has been another episode of Mysteries Unraveled. See you in the next one.